Chapter 6, Section 6, Applications of Percent Changes. This actually goes back to what we were doing in the last couple sections, where we're looking at now, instead of just doing percent increase once or percent decrease once, we're going to be doing it multiple changes, typically just twice. So I'm going to say Roman numeral 1 is going to be 2 changes. And when you have one of these, really it's just kind of like doing one problem then doing another one right after it. So I'm going to say do the problem in 2 steps as my hint for how to do it. So do the problem in 2 steps. And just going to jump right into examples. I have 3 examples I want to do in here. So the first example, I'm going to abbreviate it, kind of the writing a little bit, but say that you have a $300 plane ticket, and maybe your aunt is a flight attendant or something like that, so you're able to get a 15% discount. But you want to take your bike along with you, so you have to pay extra for that, and say they're going to charge you 15% more, plus 15% increase for luggage. If you don't like biking, maybe you're going to Siberia and you're taking so many clothes because you hate being cold, you need to pay more for that. Okay, so the question is now, what do you pay? So what do you pay? Because if you're like me, I look at that and I think, okay, 15% off, and then I pay 15% more. I want to say the answer is $300. And the question is it $300? So if we go through, I'm going to kind of abbreviate off on the side, say, well, first we're doing this 15% discount. So what do we do when we get the 15% discount? So we did percent times the original equals the new. That's kind of what we've been using as an equation for the last few days. And you remember with a percent discount or decrease, we couldn't just put in a 0.15 there. Instead, normally it's 100% of the cost, but they're taking off 15% of the cost, so it becomes 85%. So that first step we do 0.85, we're paying 85% of the original value. And 85% of 300 comes out to be 255, if you put that in. And now the second time around, we're going back up now. So now we're going up by 15%. So we're here we did 100 minus the percent increase, or decrease. Now we're adding 15%, so really it's like 100 plus the 15%. For a total of 115%. So we do a 1.15 times, well, now our value, our original value at this point in the problem is 255. That's where we're starting. And if I do 1.15 times 255, I end up with just $293.25. So 15% off and then 15% added back on doesn't get us back to the 300. It gets us to $293.25. And the part that seems a bit strange to me is in this type of question, the order doesn't matter. So up here, I said do the problem in 2 steps. Sometimes that's all you need to know. Sometimes the order doesn't matter. But sometimes it does. And if you wanted to check this, you could go back and say, all right, if I wanted to do it in the other order, maybe I should do that just to hold myself accountable. First, if you're doing the percent increase, it'd be 115% of the 300. And when I punch that in, I end up with $345. But now if you were to go back and say, all right, 15% off would be the 0.85. So if I do 0.85 of my 345, I'll end up right back at my $293.25. So, example 1, and I don't know if you wrote this blue part, I probably wouldn't have. It probably isn't going to make sense unless you go through and say up by 15%, it's right there, down by 15% is right there. Then you could say order doesn't matter. But sometimes we'll find that order does matter. So a second example, so my example 2, so I'm going to kind of do what I did before, but this time I'm going to have a $500 plane ticket. And we're going to have one change be a discount. So I'm going to say we have a 30% discount. then a $60 rebate. If you're not real familiar with rebates, often with rebates you send in your receipt and you get your $60 back in the mail a little bit later on, or a $60 credit card or something, gift card. Alright, so when we do this, we start out with a percent times the original equals the new. And I'm going to just first do this 30% discount. So if we're taking 30% off of something, we have to pay 70%. So 100% minus 30% is 70%, which is 0.7 or 0.70. We do that to our original of $500. That's going to give me $350. So the 30% discount gets my plane ticket down to $350. Now if we get a $60 rebate after that, you could take $60 off of the cost, and that plane ticket now is going to cost you out of pocket $290. Now for this, when we have a percent and then a certain amount of money, is the order going to matter there? We know it doesn't if you have 2% changes. But if we were to do this in the other order, we start out with our $500, and then we subtract our $60 for our rebate. So that gives us a total of $440. And now we say that you get the 30% off, so we're going to say down 30%. You have your percent times your original equals the whole, so we had 70% we have to pay once we take off the 30%, times my 440. If I punch that in, so 0.7 times 440 gives me $308. So you'll notice this time we get something different. If we do the 30% off first, it costs us less. It only costs us $290, where if we do the 30% after the $60 off, we have to pay $308. And if you try to think critically about that, that should make sense. Because initially, we're looking at our problem and we're saying, all right, I'm going to take 30% off of 500. In the second one, we're taking 30% off of 440. So the amount that it goes down is bigger in the first example because we're doing 70% of a larger number, which then means that we're actually taking off more in that first problem. We're taking off $150 in the first problem, where in the second problem we're only taking off $132 as opposed to the $150. So order does matter if you have a percent and like where you're adding or subtracting. So we probably should go back to that first equation that you wrote up above and add on to it and say that do the problem in 2 steps and do them in the right order. And I ended up doing this as 2 files, so I'll rewrite it again. So do the problem in 2 steps. So you should have that written right after your Roman numeral 1, and write order matters when mixing percent changes with adding or subtracting. Hopefully you can squeeze all that in there, or at least say order matters and just always do it in the order they gave you. So I want to do one more example of this before we move on to Roman numeral 2. So this will be my third example. And I want to go back to what we did in number 1. So in number 1, we had a $300 plane ticket, and then we first did the 15% discount, and then we added 15% back on. So we started out at $300. Or maybe say, here's my question. So after the 15% discount, in example 1, we found that a 15% increase didn't get us back to the $300 that we started with. So I want to say, what percent increase would get us back to that? So it's going to have to be higher than the 15. We get you back to the $300. So I'm just going to kind of slurp the numbers from there instead of doing the 0.85 times the 300. I'm going to say that, well, we're starting out at $255 because we dropped down to $255. And we're trying to say what percent is going to get me back up to 300. That's really kind of what we're looking at, what percent increase. So if we go to our equation is the percent times the original equals the new. Now these words are a little bit cumbersome when we're doing this problem because it's easy to think, well, the original is the $300. That's what we originally started with. But what we're trying to say is what percent change. We're trying to find that, so I'll put in an X. What percent change do I have to do to this 255 to get me up to the 300? So we're saying what percent change of the 255? So 255 has to go in here. What percent of that will have us get an end result of 300? So the problem ends up getting set up that way. Now if we're trying to solve for X, trying to solve for that percent, we divide by 255. That'll isolate the X, and X ends up being 1.176 if I do a little bit of rounding. So 1.176. Now if we think about changing that to a percent, we have to move that decimal 2 places again. We move it that way. So we have 117.6%. So it's tempting to say, okay, a 15% increase didn't do it, but 117.6% would. But you have to remember that in these types of problems, we were doing 100% plus the percent increase. And so it ends up being that the percent increase is actually going to be 17.6. That we take that percent plus 100 in our problem. So in other words, it's a 17.6% increase would be needed to get us back up to the $300. So Roman numeral 2, simple interest. The equation is going to be I equals PRT. And I don't know if you want to put this on the bookmark I gave you or if you want to put it in here or both, but it might be helpful to kind of define what those different things are. So I is just going to be the interest, that amount of interest that you get back if you loan them the money or if they loaned you the money, the amount of interest you owe. P is going to be the principal. I've seen principal spelled both ways when it comes to money. I'm going to stick with P-R-I-N-C-I-P-L-E, although I think our book does it the other way. But most people, I think, spell it this way. But that's going to be the starting amount. So that's going to be that amount of money that the bank loans to you or the amount of money that you put into your savings account. Then R is going to be the interest rate. Basically, what percent interest are they giving you or are they charging you? And I'm going to put parentheses below that percent as a decimal. So if you're being charged 4% interest, you'd put in a 0.04 for R. Then the very last thing we had was T. T is going to stand for time. But I want to make the clarifier that it's the same units as the interest rate. One second. So same units as the interest rate, because sometimes they'll say they're going to give you 4% a year. How much do they charge you in interest in 6 months? And a lot of people will put the 6 in for 6 months. But if it's 4% interest a year, 6 months is going to be what for time? 0.5, because 6 months is half of a year. So you'd have to make sure you're in years if your interest rate is in years. And we'll do one example of this, then wrap things up. So example 4 we should be up to. I'm going to say you borrow $40,000 for college. At 3% interest. For 6 years. how much will you pay? You may find this as being motivation to work hard now to try to get some scholarships. I know I ended up paying I owed more than $40,000 by the time I finished, and college is like 3 times as expensive now as when I went. But
yeah, I saw that on Instagram. John posted that. Wow.
$200 for college. Wouldn't that be nice? So, all right, 40,000. Where do I put my 40,000? So I have my I equals PRT, the letter P. So 40,000, because that's the principal. 3% interest would be 0.03. So if you just do the 0.3, that's going to be 30% interest. You do not want to borrow money at 30% interest. That'd be like Loan Shark. And people that give you money for gambling debts and such. Time would be 6. Perhaps I should have said 3% a year for 6 years. We'll assume that that's the same. So when I crunch my numbers at the end, I come up with that I is $7,200. So is that the total amount of money that you owe? No, everybody would borrow money. You could borrow $40,000 and only have to pay back $7,200. Sign me up. I'm getting a new bike. Okay. So, you could probably find that. Okay, the $7,200 is just the interest. So if the question's asking how much interest do you owe, this is how you do it. If they're saying how much money total do you owe, what do I have to do to the $7,200? Plus the $40,000 that we borrowed at the beginning. So the final answer then would be $47,200. In 6 years, you're paying the bank $7,200 to loan you the money for 6 years. That's it for this section.